Hi, my name is Leah, and I chose goal number 14, Life Underwater, for my final project. So this is my presentation. I'll kind of be going back and forth throughout it. I'm actually at the beach right now, so I thought that this was fitting. And I just went snorkeling at a coral reef, so I felt like it was pretty personal and fitting. I chose this goal because I love to travel, especially tropical places, and I care deeply about the health of our oceans. Since I'm spending these last few weeks of July at the beach, it feels personal and relevant. The problem identified is that the ocean pollution is accelerating, especially plastic waste and temperature change. Marine ecosystems are degrading due to human impact. This business solution creates a company that tracks ocean pollution levels and coral reef decline over time using data modeling. This info will help decision makers act faster to protect marine life. I wish that I had a presentation behind me, but okay, about my business. I named it Underwater Analytics. This is an environmental data company that uses ocean sensors, satellite data, and modeling to measure how fast marine ecosystems are degrading. We use calculus derivatives and second derivatives to calculate rates of change in coral reef health, temperature rise, and plastic concentration in the water. This helps environmental organizations prioritize things based on urgency. Here's the slide. Okay, this is my logo that I made. This Canva. It's pretty basic. It kind of matches the template. And the advertisement, I just chose a slogan. Underwater analytics, tracking ocean health before it's too late. Pretty simple, but that's my ad. Why derivatives? Here, I'll show these. Calculus helps quantify damage in a clear, measurable way. Derivatives tell us the current rate of change, while second derivatives reveal whether that rate is increasing or decreasing, acceleration or deceleration. Okay, this is my data table. Coral coverage percent in Great Barrier Reef over the years. This is actual data, so I won't read it all out, but it's from 2000 to 2020, and this is the year. This is the T, which is year since 2000. Oh, I didn't mean to click that. And the coral coverage and percentage, as you can see, it's declining pretty vastly. So this is the scatter plot. I made a graph. I made a graph for the table that was in the last slide using this equation. I'm not going to read it out because it'll take a minute, but C of T is the coral coverage and T is the year since 2000, like showed in the last slide. Okay, and my calculus problem, this is the slide. Underwater analytics found coral coverage is declining following this equation, which is C of T equals negative 0.08 T squared minus 0.2 T plus 45. And then there's parts A, B, and C of the question. So part A is, what is the rate of change in coral coverage in 2020, which T equals 20. B is the rate of decline accelerating or slowing in 2020? And C is interpret the meaning of the answers in the real world. Okay, so that was the slide. I think I showed it already. And then the solutions are here. Take a second to look at all that, and I'll read it out. Okay, for part A, for the rate of change, you had to find the first derivative, and I'm not going to read all that out. Hopefully you can pause and see part A worked out. Then you substitute T equals 20, which is the year of 2020. And then the final answer for part A is, in 2020, the coral reef coverage is decreasing at a rate of 3.4% per year. B, for the decline, you have to use second derivative, so I'll show the work again. Since the second derivative is negative and constant, this means the rate of coral loss is accelerating over time. So it's like the coral is decreasing, but the rate of coral loss is increasing. So the decline is accelerating, not just continuing. And then for C, just kind of all of it put together, in 2020, coral coverage was decreasing by 3.4% annually, and this rate is accelerating. Without help, the Great Barrier Reef and other coral ecosystems could collapse within a few decades. And then my last slide is just my reflection. Excuse me. What I learned is that this project showed me how calculus can be used for meaningful environmental change. Modeling environmental decline using derivatives made me understand both how bad the damage is and how urgent it is to respond. The social impact is that the business informs the public and policymakers about risks to food sources and biodiversity in coastal communities that typically rely on reefs for fish and other environmental factors. The economic impact is that it prevents tourism loss, like if it's helped, if that makes sense. Fishery collapse and economic damage from ignoring the crisis. Investments in reef health and artificial reefs can save billions in long term. And environmental impact is that it helps guide where to take immediate conservation action and raise awareness about reef extinction. So thank you. That was my presentation. I know it's over 5 minutes. I hope that's okay. But thank you.